Am I audible to all?
Yes, sir.
Yes, sir.
Okay, beta. Okay. Beta, partial fraction. Partial fraction. See, if we have to integrate, let's say we have to integrate this. Okay, x minus 1, x minus 2, x minus 3. Okay, till now we didn't have any method which we have learned up to today. We don't have any method to how to integrate this. So what we can do, I tell you, this is the integrand, and beta this can be written, this can be expressed like this: a by x minus 1 plus b by x minus 2 plus c by x minus 3. Okay, ABC will be some constant like 2, 4, 5, anything, minus 5. So if we have to integrate this, we will convert this into this. And you all can see this is equal to this, then this will be integrated, and this is easily integrable now. So the method by which we are converting this into this, that is known as partial fraction. Okay, so this we are going to study. Okay, so let me tell you how to use it. But this is applied to rational function. Rational function. Okay, rational function. That means in the numerator you will have a polynomial, and in denominator again you will have a polynomial. Okay, like px by qx. Okay, but before applying partial fraction, you need to check whether the degree of numerator is less than that of denominator. Okay, degree of numerator must be less than that of denominator. Okay, let's say I'm taking a example, a px plus q. This is x minus a, x minus b, x minus c. If we have to integrate it, so obviously we will integrate it by using partial fraction. Okay, you can see this is a rational function. In the numerator we have a polynomial, and in the denominator again we have a polynomial. Okay, and generally we write denominator in factorized form. If it is not in factorized form, please factorize it. So how to use partial fraction? See what we can do. We will be writing a by x minus a plus b by x minus b plus c by x minus c. What I'm saying, we can write this whole expression like this. Okay, this is the partial fraction. I'm taking one example. For example, we have to integrate 1 over x square minus 3x plus 2. Although we have a form, we have another method for solving this question, but whenever we have a rational function and the degree of numerator is less than that of denominator, then also you can use partial fraction. Okay, especially when it is factorizable. Okay, we can factorize it. What it will be? It will be nothing but x minus 1, x minus 2. Okay, now what we can do, I'm taking this integrand x minus 1, x minus 2. Okay, it is not compulsory that here we will have only 3 terms. We can have 4 terms also. We can have 2 terms also. Okay, but what is necessary here? This is a linear, this is also a linear, this is also a linear. Okay, just like this is the integrand where we have 2 factors, they both are linear. So what we can do, we can write this like a by x minus 1 plus b by x minus 2. Partial fraction says we can express this whole expression like this. Okay, like this. So we are just assuming that this is equal to this. Okay, now what to do? Further, what to do? You will try to find value of a and b. You will try to find value of a and b. Okay, you will try to find value of a and b. See what we can do here. 1 equals to, we are taking LCM here, x minus 1, x minus 2. A times x minus 2 plus b times x minus 1. Here it is x minus 1, x minus 2. ओके, ये हमने पुट किया है बेटा, ठीक है, हमने माना है कि ये इसके बराबर है. नाउ वी आर गोइंग टू फाइंड वैल्यू ऑफ ए. यस, व्हाट वी कैन डू फर्दर? यस अपर्णा, कैन यू टेल मी व्हाट वी कैन डू फर्दर बेटा? Simplify it. Okay, this will be cancelled. So what we are left with, 1 equals to a times x minus 2 plus b times x minus 1. Okay, now what we can do here, see, just expand it. 1 equals to ax minus 2 plus bx minus b. Now what we will be doing, this is ax.
We'll compare the coefficients.
Yeah, so we are basically collecting all the terms containing x, which is ax and bx together. So it will be ax plus bx, and we can take x common, so it will be a plus b into x plus minus 2a minus, it is equals to 1. Now we will just compare the coefficients. Okay, what to do? Here we have a term containing x. Here we don't have any term containing x. We can simply say that is nothing but 0x. Am I right? Is there any doubt to anyone? Now what we can do here? See, we will be just comparing the coefficient, okay? Coefficient of x and the constant coefficient. See, these two are constant coefficient, not involving variable x in x, okay? And these are the terms containing x. So just comparing the various coefficients, okay, we get a plus b equals to 0 and minus 2a minus b is equals to 1. From here we can get b equals to minus a. We can simply put here b as minus a. Just simplify, this will be minus a equals to 1. Is there any doubt to anyone? So this a is nothing but minus 1. Okay, now what is b? If a is minus 1, just put it here, it will be 1. Okay, so b is 1. Okay, now what we can do, we make it an equation 1, and now we will replace a by its value and b by its value. Okay, so from first we are getting this as equals to a by, so value of a is minus 1 plus b by value of b is 1. So see what we have to do, actually we have to integrate this, but with the help of partial fraction we have just converted this into this form. Okay, and you can see these both are easily integrable. Okay, initially it was not easily integrable, now we have written this like this, okay, by using partial fraction. So now this is the new integrand. Okay, so instead of writing this integrand, we will be simply writing this integrand. Okay, so put this in integration, or you can just integrating both sides. If we integrate both sides, what will be happen? See, integrating this, that means integrating both of them. Okay, so it will be minus 1 over x minus 1 dx plus 1 over x minus 2 dx. Okay, so now what can be done here? See, minus 1 will come outside, and what is the integration of 1 over x minus 1? Yes, Satvik will tell me. Satvik, what is the integration of 1 over x minus 1? Yes, Satvik. Varnika, what will be the integration of 1 over x minus 1? Gautam Singh.
Sir, log x minus 1.
Log x minus 1. Beta, we should take
Yes.
always a mod here, okay?
Yes,
Minus
sir.
1 is already a constant, it will be taken outside.
Yes.
Okay, so minus 1 into log of x minus 1 and divided by derivative of x minus 1. But luckily it is 1, so it will not make any difference, okay? But it should be in your mind, okay? Plus log of x minus 2 plus c. So student, this is the answer. Okay, answer is nothing but log of x minus 2 minus log of x minus 1 plus c. Okay, sometimes student says, sir, our answer is different. Because this question can be done by previous method also, 1 by quadratic method also, and there we will getting answer like this. But I use any method. Answers are always same. Okay, if both methods are correct. So see, this and this, they both are equal. Okay, if you use another method, the previous method, 1 by quadratic method, it will be like this. Answer will be like this. See, this is the same. This is nothing but log m minus log n is nothing but log m by log n. Okay, so student, this is the answer. Okay, this is one of the partial substitution which you can learn. Okay, there are many others. I will tell you what is how to do others. See, here you can see these were linear factors in the denominator. Linear factor in the denominator, linear factor in the denominator. If it is linear, here we will have a term which will be whose degree will be 1 less than that of this. Okay, this is linear. This is the constant of having degree 0. Degree 0. Constant is having degree 0. Okay. We are taking another questions. See, I'm taking this question number 4. We can do the same. Yes, students, will you try to do this question? X over x minus 1, x minus 2, x minus 3 dx. Okay, what we can do, we can take this integrand separately. Okay, yes, what we can write? Ramik, please tell me what we can write here. Here we have 3 linear factors, x minus 1, x minus 2, x minus 3. And before applying, you should check whether the degree of the numerator is less than that of denominator or not. Here it is clear, degree of numerator is 1 and that of denominator is 3. So numerator is having less degree than that of denominator. So we can apply partial fraction. Now what is partial fraction? There are 3 linear factors. Okay, x minus 1, x minus 2, x minus 3. So in the numerator will be a, b, c. Okay, constant terms one. Okay, so we will be substituting like this. Okay, now what to do? Next step. Yes, students.
Sir, we'll take LCM.
Yeah, LCM. Okay, x minus 1, x minus 2, x minus 3. And in the right hand side, students, try to do this question right now. Yes, you all will try to do this question. I can ask any one of you, any step. Try to do. We are taking LCM. LCM will be their product only. So a times x minus 2, x minus 3. B times x minus 1, x minus 3. Plus c times x minus 1, x minus 2. Okay, now what to do? This is cancelled. Okay, now with x equals to, we can multiply this. Ax square minus 5x plus 6 plus b multiplied x square minus 4x plus 3 plus c multiplied x square minus 3x plus 2. Okay, now you can just simplify. Even you can collect all the terms containing x square. So ax square plus bx square plus cx square, isn't it? I can take x square common. Okay, similarly you will multiply this a to this term. Okay, this to this term and this c to this term. You'll get all the terms containing x. This is nothing but minus 5a minus 4b minus 3c. Actually it is x. Okay, minus 5ax minus 4bx minus 3cx. You can take minus x common. Okay, and this is here 6a plus 3b plus 2c. A plus b plus c in bracket x square minus x 5a plus 4b plus 3c plus 6a plus 3b plus 2c. Okay, here it is x. Now try to simplify. What we can do here, compare the coefficient of x square. Yes, what is the coefficient of x square on left hand side? What is the coefficient of x square on left hand side? Satvik, can you tell me what is the coefficient of x square? Beta, on left hand side. Yes, on left hand side, beta, it is 0. 0 x square. If there is no such term, that means it is 0 x square.
Okay, sir.
So 0 equals to a plus b plus c. Okay, comparing the coefficient on both sides. Okay, here the coefficient of x is 1 and it is negative of 5a plus 4b plus 3c. Okay, and here the constant term is 6a plus 3b plus 2c, not involving any variable x, and there is no constant term, so that means again that is a 0. Okay, so this is like this.
Yes, sir.
You can find a from here, which will be nothing but b minus c. Okay, you can put it here. We are eliminating a. Okay, this is minus 5a minus 4b minus 3c. Minus 5 is minus 5. Instead of a, we can write minus b minus c. Minus 4b minus 3c. Okay, here again we can write here minus b minus c plus 3b plus 2c. Minus 6b minus 6c plus 3b plus 2c. Minus 3b minus 4c. Okay, and here we can get 5b plus 5c minus 4b minus 3c. It will be b plus 2c. Okay, so we can solve these two, 2 and 3. Okay, we can solve these two. I can multiply here by 2 to make the coefficient c same. Yeah, before one die. Yeah, here it is also 4. It is also 4. Okay, it is plus 4. It is minus 4. No problem. We can add them. Add 2 and 3. Okay, just multiply 2 to both sides. 2b plus 4c equals to 2. And it is minus 3b minus 4c equals to 0. Adding, this will be cancelled. This is 2. Minus b equals to 2, so b equals to minus 2. If you know the value of b, put here the value of b here. Okay, so 4c equals to 6. So C equals to 3 by 2. Okay, we know the value of B and C. We can put here. Okay, you will get value of A also. A is nothing but minus B. B is minus 2. Minus C. C is 3 by 2. This is 2 minus 3 by 2. Okay, 1 by 2. So A is 1 by 2. We have value of A, B, C. Now obviously we will be putting this here. Generally we make it equation 1. Okay, this is equation 1 and this is 2 and this is 3. So we will be putting value of A, B, C here in the equation 1. Okay, so from first we are getting 1 by 2 into 1 over x minus 1 plus minus 2 over x minus 2 plus 3 by 2 1 over x minus 2. Is there any doubt to anyone? Yes. This is equals to
Sir,
x over. Yes, beta. Just. Yes, beta.
sir, can we do it using some other method rather than comparing the coefficients?
Beta, I also prefer that, but some of the teachers in board exam they sometimes deduct the marks.
Okay,
That
sir.
is the problem. Okay.
Yes,
We
sir.
can use putting x equals to 1, x equals to 2, and x
Yes, sir.
equals to 3. Okay.
Okay, sir.
That is a little risky. That's it. Okay. I'm not saying
Sure, sir.
all teachers deduct marks, but sometimes they say ki this is not the method of CBSE. Okay.
Okay, sir.
So this is the expression x over x minus 1, x minus 2, x minus 3. Okay. What we do, we have to just integrate both sides. Integrating both sides. So if I integrate this, what will happen? Half will come outside. Integration of x minus 1 dx. Here minus 2 will come outside. Integration of x minus 2 dx. Here 3 by 2 will come outside. Integration of 1 over x minus 2 dx. Now you will get the answer. 1 by 2 log of x minus 1. Minus 2 times log of x minus 2. Plus 3 by 2 log of x minus 2. Plus c. Okay. So this is a very simple question, students. Okay, let's do one question you all will do. Question is, I'm not going to initiate even this question. You all have to start this. Integration of 2x over x square plus 3x plus 2. And do this by using only partial fraction. Okay, otherwise this is just like linear by quadratic. And for linear by quadratic, we have another method which we studied in last class. Okay, I'm saying integrate by using partial fraction because we have learned this. See, beta, first of all, we always try to check whether the degree of numerator is lesser than that of
So
denominator or
middle term
not.
splitting.
Yeah,
Middle
middle
term
term splitting. Here the degree of numerator is lesser than that of denominator. That's what we want. Okay. And further,
Yes, sir.
we have to factorize the denominator. Okay. Try to factorize this. Okay. Even you can simply, you can directly write. Okay. No need to show it by using middle term splitting. Okay. You can simply write because this thing we have done in class 9. Here you can do this in directly. Okay. You can do this in rough or you can directly write. There's no
Yes, sir.
problem. No marks will be deducted for this. Now what to do? Yes, beta. Achintya will tell me, beta, how to write here?
Sir, so we'll
Yes.
2x upon x plus 1 and 2x upon
No, beta. See,
No,
here we have a
sir,
linear
I'm telling
factor.
you.
First linear factor is x plus 1.
Sir,
Second
A
linear
upon
factor is
x
x
plus 1,
plus 2. Yeah,
A
a upon
upon
x plus
1,
b,
B upon x plus
x plus 1. Yeah, yeah. Okay. Okay, thank you, beta. Okay, so this is very simple. Now try to simplify. Yes, find the value of a and b. Students, find the value of a and b. Okay, find the value of a and b. In the numerator, you will multiply and collect all the terms containing x. Yes, beta. Okay, so this is just like a plus b into x plus 2a plus b. This is 2x. Now comparing the coefficient of x. Okay, what will be the equations? Pratna Bansal, tell me beta, what will be the equations in a and b? Pratna Bansal, comparing the coefficient of a coefficients, various coefficients. Okay, we will be getting here a plus b equals to 2, and here 2a plus b is equals to 0. Okay.
That are the answer.
Yes, beta. What is the answer?
A is equal to -2 and B is equal to 4.
Yeah. Good, beta. So by solving these two, this is number 1, this is number 2, number 3. Solving 2 and 3, we get a equals to -2 and b equals to 4. Okay. You can solve these equations in the also. It's all up to you. Okay, how fast you can be, it's all up to you. Okay. So solving these two, we get value of a and b. Now we can substitute this in equation number 1. So from here, this will be equals to 2x over x square plus 3x plus 2 is equals to a over a is nothing but -2. Okay, -2 over x plus 1 plus b over x plus 2. So value of b is nothing but 4. So instead of writing b, we will be writing 4. Okay, just from equation 1 we get this. Now integrating both sides, just integrate both sides. Okay, so the integration of this -2 will come outside, and integration of this 4 will come outside. Integration of x plus 2. Okay, this will be -2 into a log of x plus 1 plus 4 times log of x plus 2 plus c. So this is the answer. Okay, Syama Goel, I have a question for you. Can you tell me what will be the integration of 3x minus 2? Syama, integration of 1 over 3x minus 2. Syama Goel. Apadna, can you answer it, beta? Gautam, Mayank Sejwal, any one of you, please answer it. Aryan Vasist, what will be the integration of 1 over 3x minus 2?
Sir, 1 by
log
3
log
log mod 3x minus
So
log of mod of
log
3x
mod
minus
3x
2.
minus
That's
2
it.
upon 3.
divided by 3.
Beta,
Over 3.
upon. Do not forget to differentiate this in denominator, as this is a linear function instead of x. It is not exactly 1 by x. So in that case, we always write in the denominator derivative of that linear function. Okay, good. So log of 3x minus 2 divided by 3 plus c. Okay, okay. Let's take another question, students. See, we are taking another question. We have a question x over x plus 1 x square plus x plus 1. Now how to do this question? See, if this is not factorizable further, okay, this can't be factorized further, isn't it? So what to do? See, I'm taking this integrand. This is the linear factor and this is the quadratic factor. Okay, quadratic expression. This is linear expression. So for we will be writing here x plus 1. Okay, and for this quadratic expression we are writing here x square plus x plus 1. Okay, if this is linear, here we have to write a constant term a. Okay, if it would be linear, again we will be writing a constant here, but this is not a linear, this is a quadratic. If it is a quadratic, in the numerator we will be writing a linear. Even you can see here the degree of this is 1 less than that of this. Here the degree of this is 1 less than that of this. See, it is linear in the denominator in the first term, so it is a constant. Okay, it is of degree 2, so in the numerator it is of degree 1, so that's why it is a linear. Okay, so that's why we substitute this like this. Okay, now what to do? Just find the value of a and b and c. Try to find the value of a, b, c. Okay, see what we can do, just taking LCM. Okay, okay, so this will be cancelled. Okay, so this is x equals to a times x square plus x plus 1 plus x plus 1 bx plus c. Okay, so just multiply. This is ax square. In fact, this is ax square and x into bx square. Okay, so this is ax square plus ax plus a plus bx square plus cx plus bx plus c. Just multiplying. Now collecting these two, so it will be a plus b into x square. Okay, now the terms containing x, only x. Okay, so x, a plus c plus b. The constant term is a and c, not involving any variable x. Okay, here it is x. So the comparing the coefficient of x square, which is nothing but here it is 0, here it is a plus b. Okay, is there any doubt to anyone? This is with a new substitution for partial fraction. Okay, okay, because here they both are not linear terms, so that's why this is another one. Okay, is there any doubt to anyone? Yes, anyone have any doubt up to here? A plus b equals to 0, a plus b plus c. Here the coefficient of x is this and here the coefficient of x is 1. Comparing the constant coefficient, here the constant coefficient is a plus c and there is no such constant term here, that means that is 0. Okay, so just try to simplify it. Here b equals to minus a, here c equals to minus a. What I have done here, I got b in terms of a, I got c in terms of a. Okay, so b in terms of a and c in terms of a. So a equals to minus 1. A is minus 1, put it here, b is plus 1 and c is also of plus 1. Okay, now what we can do here? Yes students, what we can do? We can substitute here. This is number 1. Okay, is there any doubt to anyone? Up to here, no doubts? See what we can do. From first, we get x over x plus 1, x square plus x plus 1 is equals. Instead of a, we will be putting the value of a, which is nothing but minus 1. Okay, value of a is minus 1. B and c, 1x, c is also 1. That means the original integrand is reduced to this. Okay. Now we can integrate both sides. See, integrating this, that means integrating this whole thing. That means integrating this individually and this individually. And you all can say this is easily integrable. Okay. And what about the second one? See, we are just integrating both sides. -1 will be taken outside. Here x plus 1 over x square plus x. See, this is easily integrable. But what to do here? How to do this? This is linear by quadratic.
So linear upon quadratic.
Yeah. Here further the partial fraction cannot be used because this is not factorizable. Okay. Can you all see this is not further factorized? So no partial fraction will be used further. Now we have to use linear by quadratic. Okay. If this quadratic is factorizable further in terms of linear terms, then we can use partial fraction. Okay. Otherwise, we have to use linear by quadratic only. Okay. So here we are going to use linear by quadratic. See what to do. You all know in case of linear by quadratic. Syama, can you tell me, beta, what to do here for linear by quadratic? What we put linear as? Linear equals to. Yes.
Yes.
Arnav, can you tell me? Arnav. Asna.
Third linear would be to A.
Yeah. Good, beta. Linear equals to A. Derivative of. Yeah. Beta,
Plus B.
since I've used here A, B, C, so I just want to change the name now. Or generally we write A only. Okay, but I can write here P also. There's no problem. Yes, beta, tell me again. Linear equals to, you are saying A times derivative of denominator plus B, but A and B are used, so you can use P and Q. Okay, not a problem. Okay, do x plus 1 equals P. This is 2x.
2x plus 1.
Yeah, beta. Beta, can you tell me next step? Yes, please tell me. Next step, beta.
So we would find out the value of P and Q by comparing the coefficients.
Yeah. So 2px plus p plus q. Okay. So what to do? Just comparing the coefficient on both sides. Here the coefficient of x is 1. Here the coefficient of x is 1. Sorry, 2p. So 2p equals to 1. Okay. And the constant term is p plus q, and here it is 1. So p plus q equals to 1. Here p is 1 by 2. Now put it here 1 by 2. Find q is again 1 by 2. Okay. So what to do? Just writing x plus 1. We will be putting here. Okay. This is third. Okay. This is second equation. So x plus 1 equals to p is nothing but half of 2x plus 1 plus q is nothing but 1 by 2. Okay. Now what to do? See, we should make here 2. This is third. Okay. Now dividing both sides by x plus 1 by x square plus x plus 1 equals to half of 2x plus 1 by x square plus x plus 1 plus half of 1 over x square x plus 1. Okay. Now what to do, beta? Integrating this. Okay. Or you can simply replace this, because now this is easily integrable with the help of this. Okay. We can simply put this in second. Okay. Put it in second. Okay. So in second, what will be? This is our original integral. Let it be I. So I equals to integration of 1 over x plus 1 dx. Okay, plus integration of half into 2x plus 1 into x square plus x plus 1 plus half into 1 over x square plus x plus 1. Okay, we can separate this. Okay, plus half integration of x square plus x plus 1. See, the first one is easily integrable. Okay, what I do, I always integrate simultaneously. Okay, here what we can do, we can use substitution method here, because in the numerator this is nothing but denominator's derivative. Okay, so here we have put t equals to x square plus x plus 1. Okay, for the second integral. So dt by dx will be 2x plus 1. So dt equals to 2x plus 1 into dx. Okay, is there any doubt up to here? Any doubt to anyone? What to do? 1 by 2. This is nothing but dt, and here it is t. Okay, for this what to do? This is a coordinate square plus x plus 1. X square plus x plus 1. You know, I told you one direct formula, x plus minus b ka whole square plus c minus b ka whole square. What is b? And here we should take x plus or minus. If it is plus, we should take plus. So I'm taking plus. Okay, and b is nothing half of coefficient of x. X coefficient is 1. Okay, so half of 1 is half into 1, which is half. So b is nothing but half. We will be using this formula. X plus half ka whole square plus c is nothing but, c is already given, always given. This is 1 minus 1 by 2 ka whole square. Okay, you can likely use. There is no problem at all. Okay. So what to do? X plus 1 by 2 ka whole square plus 1 minus 1/4. Okay. Now what to do? 1 minus 1/4 is 3/4. Okay, and we are making this a perfect square. X plus 1 by 2 ka whole square plus 3 by 4, which is nothing but root 3 by 2 ka whole square. Okay, so instead of writing this, we will be writing this. Okay, now just integrate all. Just integrate all. This is nothing but minus of log of x plus 1 divided by derivative of x plus 1, that is again 1. 1 by 2 log of t plus, yes, who will tell me formula for this? Yes, Riddhi, can you tell me formula for this, beta? Riddhi, x square plus a square, integration of 1 over x square plus a square. What is the formula? Riddhi Gulati?
Sir, can I?
Yes, beta.
Sir, it is 1 upon a into tan inverse x upon a
Very good, beta.
plus c.
Very good, Sadhul. 1 upon a, see this is a, okay? 1 upon a, tan inverse x by a. Here x is replaced by a linear function. I told you in formula x can be replaced by any linear function. So x over a. But in that case, actually we should do divided by derivative of x plus 1 by 2. But here it doesn't make any difference as it is 1 only, okay? Divided by derivative of x plus 1 by 2, which is 1 only, so it will not make any difference. So this is 1 by root 3. Okay, 10 inverse. What we do? I am multiplying 2 to numerator and denominator both. So this will be 2x plus 1. And here it will be root 3. Okay, plus c. Rest will remain same. But in the second term, we can replace t. What was c? T is here, x square plus x plus 1. Okay, so this is your answer. Okay, is there any doubt to anyone? You just have to remember this substitution. Okay, this substitution. Okay, see, I'm again repeating. Suppose we have x square over x minus 1, x plus 1, x plus 3. Okay, see, this is linear, this is linear, this is linear. Okay, so there are three linear terms, x minus 1, x plus 1, x plus 3. No worries. Okay, we will take them separately, but in the numerator it will be a constant term, a, b, c. Okay, suppose if we get such question like this, x minus 1, x plus 1, x square minus x plus 1. Now we have three factors and this cannot be factorized further. That's all. So what to do? There are three factors, two are linear, x minus 1, x plus 1. Okay, and x square minus x plus 1. Okay, so this is a linear, so here we will have a constant term a. This is a linear, a constant term b. This is not linear, this is a quadratic of degree 2. So here it should be a term of degree 1. This is of degree 2, so it should have degree 1. This is nothing but cx plus t. Okay, so we assume like this. This is very simple. Okay, so we have done these two types. Okay, we are taking third type, which is let's say we have a question, integration of x plus 2, x minus 1, x plus 3 ka whole square. Okay, now in the denominator it is factorized. Okay, further we cannot factorize. Okay, this is in factorized form. There are two linear terms, but the second linear term is repeated two times. Okay, x minus 1, and this is x plus 3, but this is x plus 3 ka whole square. Okay, so this is something new to do. For this linear term, no worries, we have to write here x minus 1 in the numerator a. Okay, and this is also a linear term but repeated two times. Since it is repeated two times, you will repeat it two times. Okay, but first will have power 1, second will have power 2. Whole power is 2. Okay, so we'll start with power 1, power 2. Okay, if it is whole power 3, let's say here it is whole power 3. Okay, so we will take the third term also like this. Okay, but in the numerator it will be only a constant term, because we are treating this as linear term which is repeated two times. If it is repeated three times, no problem. In the numerator it will be only constant term b, c, d, and since it is not 3, it is only 2. Okay, so we will stop at 2 only. Okay, is there any doubt to anyone? If there is any doubt to anyone, see, this can be done like this. Okay, it is repeated two times, so there are two such terms. Okay, one term is having power 1, other term is having power 2. See, I'm telling you one more. Let's say we have a question like this, x raised power 3 into x plus 1. See how to assume this. Again, we have linear term which is x plus 1. So here we can have a. This is also a linear term x, simply x, but repeated three times, x cube. Okay, so we will be writing x, then x raised power 2, x raised power 1, x raised power 2, x raised power 3. Okay, and here it will be b, c, d. Is there any doubt to anyone? Yes, we have to substitute like this only. Okay, is there any doubt? Yes, students, is there any doubt?
No, sir.
Okay, these substitution you all need to learn it. Okay, so we will do our question. See what to do. But by comparing the option, we can do all questions. Okay. See, this is x plus 2 equals, this is x minus 1 x plus 3 का whole square. X minus 1 x plus 3 का whole square. Here we have to write x plus 3 का whole square plus b times x minus 1 x plus c times x minus 1. Okay, this is cancelled now. So this is x plus 2 a times x plus 3 का whole square plus b times x square plus 2x minus 3 plus c times x minus 1. Okay, so what to do now? This is nothing but ax square plus 9 plus 6x. It is not necessary to expand everything. Okay, it's all up to you. If you want to compare the coefficient of x square, see, in both the side the highest power is 2, so we can compare the coefficient of x square, comparing the coefficient of x, comparing the constant coefficient. Okay, so simply comparing the coefficient of x square, this is ax square bx square. Okay, so this is nothing but a plus b x square. Here it is no such term, so this is 0x square. So a plus b 0. Okay, next comparing the coefficient of x. Okay, see, what are the coefficient of x? Beta, this will be c. Beta, can't you see? I should write here c. No one is saying. You should tell me. Okay, c into minus 1, it will be minus c. So comparing the coefficient of x, this will be 6a, this will be 2b, and this will be c. And here the coefficient of x is 1. So this is the second equation. Okay, and what will be the third equation? See, the constant coefficient. Constant coefficient is nothing but 9a, and it is 2. This is the constant coefficient. Okay, or you can simply get constant coefficient by putting 0. Okay, in on both sides. If you put both sides x as 0, if you put both sides x as 0, we will be left with 9a and minus c and minus 3b. Okay, and here we are left with 2. Okay, so these are 3 equations. Just solve it. B is minus a. I will replace b in terms of a. 4a plus c equals to 1. Here it will be 9a minus c minus 3 into b. B is minus a. Okay, so this will be 12a minus c equals to 2. Okay, we can solve these two simultaneously. Okay, 4a plus 12a minus c. This is 1 and this is 2. This is cancelled. This is 16a equals to a is 3 by 16. A is 3 by 16. Okay, now we put this a here to get b. So b is minus 3 by 16. And c, for c you can put a anywhere. Let's say from 2. 1 equals to 4 times p by 16 plus c. Find the value of c. 1 minus 12 by 16. Okay, this is 1. So we got the value of a, we got the value of b, and we got the value of c. Is there any doubt to anyone? Yes, students. Now we have to just put it here. This is generally 1. We can put value of a, b, c. Okay, so we have to simply substitute here. Okay, c, a, b, c. So the whole equation will become x plus 2 x minus 1 x plus 3 का whole square. This is x minus 1 x plus 3 x plus theta whole square. Here we have to write value of a, which is 3 by 16. Value of b, which is minus 3 by 16. Value of c is which is 1/4. Okay, integrating both sides. Students integrating both sides. Okay, what we can do here, we have to take this constant outside. 3/16 integration of 1 by x minus 1 minus 3 by 16 integration of 1 over x plus 1 plus 1/4 integration of 1 over x plus 3 power. See, now every integral is easily integrable, isn't it? What we do is answer will be log of mod of x minus 1 divided by 1 minus 3 by 16 log of mod of x plus 1. Okay, see what we can do here. Integration of 1 by x square is nothing but minus 1 by x. Why? Because derivative of 1 by x is minus 1 by x square. Okay, so it will be nothing but minus 1 over x. But instead of x, we have to write x plus 3. So divided by derivative of x plus 3, which is nothing but 1 plus c. What I'm saying, you can learn this also. One integration of 1 by x square is nothing but minus 1 by x plus c. Okay, as derivative of 1 by x is minus 1 by x. So that's why we have just written here minus 1 by x. But instead of x, we are writing x plus 3. So that's why you will divide derivative of divided by derivative of x plus 3, which is 1. Okay. So student, this is the answer. Okay, this is the final answer. Okay. So see, if we get a question like this, integration of x square over x minus 1, x minus 2. Okay, now what to do? I told you we have to use partial fraction only when the degree of numerator is less than that of denominator. But here the degree is 2 and here also the degree is 2. So in that case, what we do? We divide. We divide dividend by divisor. Okay, and we write like this as quotient plus remainder by divisor. Okay, so this is the way. Okay, so here what to do? Here we need to divide x square by x minus 1 x minus 2, which is nothing but x square minus 3x plus 2. Okay, this is same. So we will divide x square by x square minus 3x plus 2. Now we will divide it. Just divide it. X square, we will multiply x square with 1 to get x square. Multiply it. We'll get like this. Minus plus minus. We have just divided. This is 3x. This is minus 2. We know this is the remainder. Why? Whenever the degree of this is smaller than that of divisor, then this is the remainder. Because the degree of remainder is always less than that of divisor. So this is 3x minus 2, which is of degree 1, and this is of degree 2. So this is the remainder. This is remainder, this is quotient, and this is divisor. Okay, and this is nothing but dividend, and this is nothing but divisor. So dividend by divisor will be nothing but quotient, which is nothing but 1, plus remainder, which is nothing but 3x minus 2. We are using this formula. By divisor, x minus 1, x minus 2. Okay. What to do? We will integrate them separately. You all will try to do this question at home. This is your task. Okay. You all know how to solve it further. Okay. This will be done with the help of partial fraction, and I want you all to do by using partial fraction only. Okay. Bit of from NCERT, you have to do question number 1 to 14 from this exercise. Okay, which is of partial fraction. It is 5th exercise, 7.5. Exercise 7.5. Okay, try to do question number 1 to 14. In next class also we will continue partial fraction. We'll do some more questions on partial fractions. Okay, but the basic concept is taught to you today. Okay.